Hello there. In this lesson, we're going to learn about the Earth and some of the properties of our planet that cause the effects that we can observe every day. So first of all, as most people understand, the Earth is a ball, spherical object that is in orbit around the sun. And we have the Earth rotating and revolving. So we have terms for both of those things. So that orbit around the sun once per year, that's called a revolution. Revolution. Talking about a revolution. And then the rotation is what it does each day, right? So it turns on its axis, and that's called rotation. So rotation happens once every day, and a revolution happens once every year. So because of that rotation, it looks like objects are going across the sky or moving around us. Of course, it does appear that they travel across over top of us, but it's an illusion due to the fact that we're on this ball that's revolving, and we can't really feel the revolution, but we can see the effects on the other objects that are up there in the sky. And so objects like the sun, of course, will rise in the east and set in the west each day. And depending on the point in the moon cycle, you'll also see the moon rise at some point and set as well. And all of the stars do the same thing because the Earth is turning the same way all the time. And so all the objects will be traveling along a pathway in the sky as we rotate underneath them. So initially, observers from planet Earth would look out and see all this rising and setting that everything seemed to be doing, and it felt like we were in the center of everything that was, everything that could be observed out there went around us. And so this hypothesis or theory based on the evidence that we had was that the Earth was the centric, geo meaning the Earth. This was the idea that the universe must all be revolving around us. But it was just an illusion based on our spinning ball that we're on. And it turns out there were a couple observations that didn't make sense because of this, and we'll learn a little bit about that later. But the only way to make sense of all the observations was to put our planet, the Earth, as another one of the planets that's in orbit around the sun. So when you put the sun in the center, the fancy word for that is helio, for sun-centric. And so ding, 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 this one fits all the evidence. This does not. And so this hypothesis had to be thrown out once more evidence was presented. So everything in the sky seems to rise and set or move around us, except for one object. And that object is the North Star. And so if you watch the stars at night, or if you have one of those cameras that can take a really long exposure if you're in a place where the sky is dark enough, or if you just come back over and over every couple hours in the evening and look up at the sky, you'll see that everything in the sky moves. You can see these bunch of stars move. You can see them from this point in time going this way, ending up down here, and then later in the night, there's the Big Dipper there, and it moves around until it's down here. And so they'll continue to move through the night as our Earth turns. But the one point in the sky that doesn't change is what we call the North Star, which is directly over top of the North Pole. So our Earth is rotating on its axis here. And if you go straight above the axis, way out into space, you get to the North Star. And that's why, because it's directly over our axis, it doesn't appear to move at all. And so, yeah, that's Polaris, also known as the North Star. Now, it's been that way for thousands of years, but it's slowly moving as well. The tilt of our Earth is not perfectly stable. And kind of like a top, you know, that wobbles as it runs out of energy and then finally falls over. Well, the Earth's not going to do that because there is no over in space, but it is wobbling slightly on its axis. And every 20 some thousand years, the Earth goes through one wobbly cycle. And so over time, the wobble will end up pointing our north towards another star. So instead of Polaris being our north star, in another, 12,000 years or so, Vega, which is another fairly bright star that we can observe, that'll be the north star. And that's because this wobble will eventually shift from being pointed, kind of to the left from this perspective, then over to the right, depending on where you are looking at it in space. And so we'll end up with a new North Star in 12,000 years or so, and then 12,000 years later it'll be back to Polaris. And in between, of course, we won't have a North Star that's a bright one anyways, that's directly over the pole. So that Earth's tilt also gives us all of our seasons here on Earth. So I live in Canada. Most people watching this probably live in Canada, and we are always in tune with the seasons because it changes what you can do outside and where you can drive and the activities that you're going to do for fun, and so it's that tilt that gives us all those seasons. Now, when you're living down at the equator here, well, you don't get seasons. You might get a little more rain at some points of the year than the others, but the temperature doesn't fluctuate as much as it does when there's a tilt. So that tilt, which is about 23 degrees ish, off of perpendicular to the rays of the sun, or the orbit around the sun. That's what gives us our seasons. This particular position, you can see that there's a lot more night than there is day in this, right? So this is night. This would be a long night and a shorter day. So this would be wintertime in the north, up here. Now down here in the south, if you're riding around down in, say, Argentina down here, then you got like long days, right? Long days, short nights. And so it's going to be summer down in Argentina when it's winter up here. So the tilt gives us our seasons. Yes, so as the Earth travels around the sun with its nice tilted axis, you get 2 points at which the tilt is either fully toward or fully away from the sun. And so those 2 points are called the solstices. Now, if you're in the north, and this is the tilt being completely as far as it will go towards the sun, then this is going to be the summer solstice. And that usually is around the end of June, 21 or 22. And then 6 months later, when the tilt is completely away from the sun, this in the north we call the winter solstice. And that's my birthday, December 21st, or thereabouts. So yeah, those are solstices. Longest days, shortest nights, or vice versa. The summer solstice, longest day, and winter solstice, longest night. How long they are depends on where you are on the ball. If you're above the Arctic Circle, then the sun never rises in the winter. And if you're above the Arctic Circle, then the sun will never set at the solstice point. The equinox is halfway in between. So if this is the summer solstice, and the Earth is traveling this way around this ball, this will be winter. So if this is the longest day and the shortest night, and this is the longest night and the shortest day, at halfway in between, you've got equal day and night. There'll be 2 points at which there's equal amount of day and night. So those are called the equinoxes. And this one here in the fall is called the autumnal, because it happens in the autumn. And this one here in the spring, sometimes called the vernal equinox. So there you go, some different points on our yearly journey around the sun. One other thing you might notice if you are paying attention to the skies around the solstices is that the sun will be lower in the sky in the winter because we're on the ball tilted away from the sun. And so at noon on my birthday, December the 21st, which is the winter solstice, then the sun will be fairly low. So this would be like winter. Low in the sky, shorter days, you don't see the sun as much. And then as we travel around and the tilt is more toward the sun, well, you get these days where the sun is way up high in the sky and get nice long days, and that's the summer. So that's another neat observation that you can make just looking out at the sun daily. Of course, don't look directly at the sun. You know, you can kind of see it or glimpse it. Or you can get the special eclipse viewer things and you can look straight at it if you want.